Thank you all very much for inviting me here. I think in listening to the discussion that's been happening, there are four things that keep coming up: the idea of data localization, the idea of network neutrality, the idea of taxation of services, and the idea of sender pays settlements. So from the conversation, you'd think that these things are related to each other, but they're not. These are four completely independent issues, and when you see them conflated, when you see them put together, it's because someone is trying to make something simple more confusing. So what are these four issues? Data localization is fundamentally about performance, about privacy, about law enforcement. It depends whose point of view you're looking at it from. From the point of view of an engineer, it's about putting the data closer to users, because speed times distance equals cost. And the engineer is trying to reduce the cost, and they're trying to increase the speed, which means that they have to decrease the distance. So data localization is about making it faster and cheaper and better from an engineer's perspective. From a policy perspective, it's about who controls the data, who gets to see the data, who gets to use the data. So if it's the job of the Korean government to protect the privacy of the Korean people, then it stands to reason that it may also be the job of the Korean government to protect the data of Korean people from parties overseas who would monetize it for their own benefit. Or maybe the Korean government says that's not their job. It's not my job to tell the Korean government what to do. Lastly, as has been pointed out, law enforcement likes for the data to be somewhere where they can touch it, where they can go and get the hard drive and use it as evidence. How about net neutrality? Network neutrality is about preventing anti-competitive behavior. If you have a big market-dominant internet service provider that has a large group of customers who want to talk to things, that large provider can threaten to harm their own customers if their customers' trading partners don't pay, right? So this is essentially extortion. And if what an internet service provider is providing is not actually access to the internet, then that's false advertising. Again, there's a governmental interest here in protecting the public, protecting consumers, if they're being sold something that is misadvertised. Then there's the question of taxation of services. The government needs revenue to fund its operations. That comes through taxation. It is the right and job of the government to take care of that taxation, make it happen. There are many different kinds of taxes. Taxes on services are one of those kinds of taxes. It's a policy question of whether that's a better kind or a worse kind, whether that conflicts with agreements on international trade. You know, these balances are, again, not my issue. The one that I think is most important, though, is this question of sender pays settlements. So this is the business model of the telephone network, and before that, the telegraph network that it grew out of. So this is a business model from the 1800s that got dragged forward into the 1900s, but was pretty much over by the 1990s. By the 1990s, this had been rendered obsolete by peering, which is the internet business model. the internet is very, very different than the telephone network. There are people who try to compare them because they think, well, on the telephone network, I called people and talked to them, and I can do that on the internet also. Therefore, they must be similar. But no, not really. There are people who say, well, I was able to put a modem on the telephone network and cram a few bits of data through it. But I can do that on the internet much better. Therefore, they must be similar. But no. 10 years ago, in work we did for the OECD, we found 10 years ago that the internet was able to move bits 5 orders of magnitude cheaper than the telephony network. Right? This is an apples-to-apples comparison of the best technology available in the telephony network and the best technology available in the internet, 5 orders of magnitude cheaper. These are radically different numbers. If you were charging 10,000 times more for the same service, you can afford a lot of lawyers, and you can afford a lot of government affairs people and lobbyists. You can afford a lot of people to try to muddy these issues, to try and conflate things and confuse people in order to retain that 10,000 times price advantage. But really, these are 4 completely separate issues. The first ones there were dealt with this morning, or earlier in the day. So I'm going to go on and talk not so much about sender pays settlements, but about how the internet actually works, so that you can see why this is not applicable. This morning in a conversation, I was trying to explain why it is that talking about sender pays on the internet is not applicable, why it is that trying to drag that forward more than 100 years to apply it to a modern technology doesn't work. And I said, this is like the tax authority saying, 100 years ago, we taxed elephants on the length of their toenails. Therefore, we're going to tax you on the length of elephant toenails. And we say, but we're the internet. We don't have elephants, much less elephant toenails. And the tax authority comes back and says, but you're smart people, you can fix that. Go get some elephants and we'll tax you on the length of their toenails. This is what the idea of data localization as a mechanism for taxation combined with settlements is like. It makes no sense at all. It's from a completely different technology. So, the economy of the internet and the topology of the internet are inextricably interlinked. You can't separate the two, and you'll see why in a minute. The internet is a network of networks, right? So its building blocks are themselves networks. Internet service providers interconnect with each other, and this forms the internet. The internet is the network of networks that use the internet protocols as defined by the Internet Engineering Task Force. So if you implement the IETF protocols and you connect to another network, you're part of the internet. If you do something else, that's fine, but it's not the internet. Those building blocks, those networks, come in 4 distinct stages of growth, and they fit together in 2 different ways. So people often draw the internet as this big vague cloud, right? And people think, gosh, well, what's inside that cloud must be very complicated. There's complication in there, but if you just want to understand the economics of it, not how to build it at a technical level, all you need to understand are these 4 kinds of building blocks and the 2 ways they interconnect. So the first stage of growth, you have an internet service provider. Sorry, the text didn't make it through to PowerPoint, but so you have an internet service provider network, and they have customers, and the customers buy transit service from the internet service provider, and the internet service provider in turn buys transit service from a larger internet service provider above them in the hierarchy. Now, those arrows show the direction of money flowing. The customers pay the internet service provider pays another internet service provider above them. So this first stage of growth is a simple middleman. Being a middleman is sometimes a dangerous position to be in. For instance, if you're paying upstream in one currency and collecting money from your customers in a different currency, you're in the currency speculation market, whether you want to be or not. Dangerous place to be. Also, you're collecting a little bit of a margin on everything that goes through. So if you haven't planned your business well and that margin goes upside down, then you're losing money, but you don't have a lot of control. There isn't much you can do to fix it. So internet service providers typically try to get out of this situation as quickly as they can. They grow by adding a second upstream network. Now, by adding a second upstream network, you think, doesn't that just make the same problems worse? But actually it doesn't. It helps in two ways. Redundancy means that if one of those upstream networks fails, the other one is still likely to be working. And efficiency means that each of those two upstream networks has a different view of the world, different ways of getting to places. And you can decide which one of them you're going to use to deliver each packet. So you can always choose the most efficient one. So by doing that, you can provide your customers with a more reliable service than you're getting from either of the upstream networks, and also a more efficient service, a closer path on average to things in the internet than they could buy from either of those. So by being smart, you can take two bad services and make a good one. And so this is the business internet service providers try to get into as they get larger. The third phase is to add a connection to an internet exchange point. Internet exchange points are where the internet bandwidth is produced. For quite a while, the internet exchange point in Seoul was the largest one in the world. In the year 2000, Seoul led the world. That lead has gradually dissipated, and Seoul is now no longer even in the top 30 or 40 because of poor policy. So by adding a direct connection to an exchange point where the bandwidth comes from, the business model here has taken a radical shift. Instead of having to pay money out for every bit that gets delivered to you by a customer, now you can take bits in from the customers and get paid, deliver them through the exchange point at no cost. The horizontal connections in the network are peering, the vertical connections are transit. The vertical connections are associated with money, and the horizontal ones are not. The horizontal connections are at will between peers, between two networks that agree that it's valuable to both of them to interconnect. The vertical connections are between a service provider and a customer who agree to exchange services for money, right? These are very different kinds of relationships with very different responsibilities. The horizontal connections, there's no responsibility, right? It is purely at will, purely at mutual benefit, right? But there's no transaction that happens. There's no money that is exchanged across the horizontal connections. And then the fourth and final stage of growth is simply connecting to multiple internet exchange points. There is no network in the world that is so big or fancy that it is not described by this model. I didn't really introduce myself. I run Packet Clearinghouse, which is a nonprofit organization that supports critical internet infrastructure. We provide non-commercial services to the core of the internet. So I run a network, just like Google has a network, and Facebook has a network, and Apple has a network, and so forth. And we are present in 200 different data centers around the world, each one where there's an internet exchange point, because that's where we get the bandwidth. So 200, there aren't really any networks that connect in more places because we connect in a lot of very small places as well as the large ones that make sense for commercial operators. So, for instance, we're in Dar es Salaam, but Google or Facebook would not find it economically advantageous to be in Dar es Salaam. So that was 4 stages of growth. Every network in the internet matches one of those 4 stages, and they're all connected to each other, either horizontally through peering or vertically through transit. That's it. That's the whole thing. Nothing more complicated than that. So let's put that together so you can see what it looks like when you have multiple networks that are interconnected with each other. So we've got some stage 1 networks, some stage 2 networks, some stage 3 networks, some stage 4 networks, and some internet exchange points. And the stage 1s are buying transit from others. The stage 2s are buying transit from multiple others, as are the 3s and the 4s. The 3s and the 4s also connect to exchange points. The 3s to 1 exchange point each, the 4s to multiple exchange points. And each of these networks has customers. Now, if 2 customers want to talk to each other, so one wants to talk to a different one, then each of these providers has to find a path through that works. Now, this stage 1 provider will send it through their transit link to this stage 4 provider that they have a relationship with, and they pay money for that service because that's transit. So the stage 1 network doesn't have to worry about how this is going to happen. They just shovel all of their bits into that one connection, pay their money, and they're done. It's a simple business. The stage 4 network, on the other hand, has to look at these big routing tables, border gateway protocol routing tables, that tell it how it can reach this network over here. Now, several paths are possible. One, no, sorry. So you can see that several paths are possible, but we always try and take the shortest one because speed times distance equals cost. We're trying to minimize our cost and maximize the speed, so we always take the shortest path we can. So if these lines actually were representative and I'd thought better about how to build this slide, I would have gone out this connection or this connection, but I didn't. So we'll get to that in a minute. That stage 3 network is buying service from the 4, and the 2 network is buying from the 3, and so now we have a complete path through. Now, the vertical connections, the red ones, money is flowing up, and the value of the service is being derived from the peering connection that is the center of the internet exchange point. When we say internet exchange points are the factories that produce the internet's bandwidth, what we mean is that that's where the value comes from. The value derives from the center of the exchange point, and no money flows through the exchange point. All the money goes up towards the exchange point, but ends before it arrives there, and the value derives from the exchange point and goes down to the users. So you can think of the exchange point as like a farm that's producing bananas, and the internet service providers are trucking companies that go to the farm, they get the bananas, they take them to users, and the users eat the bananas, right? It's not more complicated than that. Okay, so let's look at this for a round trip, because internet traffic is not unidirectional. You don't send bits in one direction and then nothing comes back. It's always a transaction. There's always a query and a response, or an initiation and an acknowledgement. So here we've got a customer that sends a packet to their internet service provider. Their internet service provider will always take the shortest outbound path of the 2 possible paths here in order to minimize their own cost. Now, the other internet service provider has a higher cost because of longer distance, inbound. They deliver their packet to their customer and they get paid. So both internet service providers have gotten paid. The green one however, has had a higher internal cost. That's their problem to deal with. But it's also their right to set their price to their customer. This is very different than in the telephone network, where there would be regulation of pricing, regulation of settlements, negotiation between governments, lots and lots of overhead that's very difficult and expensive to maintain. In the big telephony networks of the 1900s, a big network might have 10 interconnections. A big internet network have 10,000 connections. If you had to have 10,000 legal agreements negotiated by lawyers with lawyers on the other side and renew them every year, it would be a huge department of lawyers just to stay on top of that. But if there's no money changing hands and it's purely at will, at mutual benefit, there's no need for the lawyers and the paperwork and so forth, so we can have 10,000 connections instead of 10 connections at a 10,000th the cost. I'll get more to that at the end of the talk. So the response comes back, green customer to green network. The green network makes exactly the same decision, shortest outbound path, which means that this time the red network has the long inbound path and delivers to their customer and gets paid. So it's always short outbound, long inbound, which gives us a rotational symmetry rather than a mirror symmetry, but it's fair. But fair is not the goal. The goal is for everyone to make money and get the services they want. It's not about being fair, right? We don't try and spite someone else just because we're not doing as well. That's a waste of time. We're all just trying to do as well as we can internally. So the red network is responsible for its own costs and its own revenue. The green network is responsible for its own costs and its revenue. At the very end of the telephony networks, at the end of the 1900s, they tried to figure out whether they could adapt their networks to this model in order to capture its advantages. And they weren't really able to, but when they did, the phrase they used was bill and keep. Bill and keep meant you build your own customers and you kept the money. It's a revolutionary idea that they got from the internet. Okay, so internet bandwidth is a perishable commodity, like a banana. It's produced at exchange points. It's consumed by people and organizations. There's a ratio of production and consumption, right? So people are, as a country, for instance, with internet exchange points, you'd be producing a certain amount of bandwidth, and the population of your country would be using a certain amount. So you've either got a net positive production or a net negative consumption, right? The country that produces the largest net export of internet bandwidth in the world is the Netherlands. So they care a lot about these issues. And Germany is number 2. So there's this ratio of production to consumption. Shortfalls have to be met through importation, right? If you're consuming more than you're producing, you need to make up the difference with importation. And importing bandwidth means that you have to send cash out. So as a country, you want to be a net exporter if you can, because that brings cash in. And value decreases as a function of time and distance. This is why it's perishable like a banana. The longer the banana has been bouncing around inside trucks, the less valuable it is by the time it gets to the consumer, right? Okay, so just to give you an idea, there are 540 exchange points right now, and that's how they're distributed. You can see why Europe has really good price performance, because they've got a lot of exchange points in a fairly dense area. They have about 120 exchange points in Europe, which is a smaller geographic area than the United States. The US has more than any other country, 110, but it's distributed over a larger area. Brazil has 30. So Brazil, I think Russia just overtook Brazil in the number 2 spot. Okay, so this peering relationship, this horizontal relationship, the OECD has us do a survey every 5 years, and we finished the second one of those in 2016. we analyzed just short of 2 million of these interconnection agreements, representing about almost 11,000 different carrier networks in 148 countries. That was all 35 OECD member countries and 21 of the UN least developed countries and a smattering in between. How dark the countries are on the map here is an indication of what the total number of responses we got from each country. It's a little misleading because in the biggest ones, US and Russia, I don't remember what the actual numbers were. I think we got about 20% response rate, whereas a lot of the African countries, we had 100% response rate. Every network gave us all of their interconnection agreements to analyze in a lot of the African countries. So key findings. 99.93% of peering agreements are informal handshake agreements. So 0.07% of agreements have a piece of paper, a written document that formalizes them of some kind. Now, often that's a web page that says, if you appear with us, here's what you're agreeing to. So that's up from 99.51% 5 years before in 2011. We did a lot of follow-up interviews, and what we found was that the people who had agreements in 2011, by and large, had let them expire. The written agreement had expired between 2011 and 2016, but the connection itself was still operating, right? So they're continuing to exchange traffic, more and more traffic every year, but they let the written agreement go away because it wasn't doing anything useful for them. Okay, 99.98% of peering agreements had symmetric terms. That means that all but 1 in 4,800 were identical terms on both sides. You could reverse the names of the two parties and you'd have the same result. So what this is saying is that 1 in 4,800, one of the parties is giving or getting something that the other party doesn't get, or they're giving and getting different things, right? So the really remarkable thing about this is if you imagine a regulatory regime, any regulatory regime, do you think that you could get 99.98% uniformity in anything you were trying to regulate? No, doesn't work. Now, imagine 200 regulatory regimes around the world trying to get that kind of uniformity. It doesn't work. The private sector can do this through market forces and competition, but governments can't because there are too many governments and they have too many ideas about what should happen. And there's a strong preference for a country of governing law. Where there is an agreement, they tend to like the US, Canada, Finland, Japan, and Iceland. They tend to dislike Cambodia, China, Thailand, Romania, Ukraine, and Russia. So in 100% of the cases where one of the parties was in the US and one was not, they chose the US as the country of governing law. In 100% of the cases where Russia was one of the countries and the other wasn't, they chose whatever the other one was. Okay, I'll just pop through a few of these. So we haven't seen Korea in these slides much because, as I said, Korea's been on this very sort of long, slow downward slide since about 2000 because of weird policies and being inward looking, right? In 2000, you had a huge amount of growth, mostly like in the late 90s, up until 2000, 2001 in there, because you've got a big population in one city and not a lot of people using Hangul characters outside of that city, right? It's written communication mostly and video and so forth. You know, where do people speak Korean? They speak Korean in Seoul and in Los Angeles. And there's a lot of fiber between Seoul and Los Angeles. So here's one where Korea does show up. It's the third or fourth to last in that. This is showing the number of interconnection pairs within the country. how many interconnections are there between networks that occur in the country. This is log scale. So Indonesia has just over 1 million, and Korea has 1,000, just under 1,000, right? So in terms of the amount of value being produced, Indonesia is doing a lot better than you guys are now. And that's a big change from 15 years ago. So I'm going to leave it at that. And I think we'll go on to the panel.